without further ado, I will introduce Caveon CEO and Chairman Dr. David Foster, who is going to present this month's session on applying information integration theory to setting cut scores and other tasks. Dave, take it away.
Okay, thanks, Steve. You can hear me okay?
Just fine.
I'd like to welcome all of you to the webinar today. This is an exciting topic for me. I'm gratified to see so many people interested in perhaps a new method of setting cut scores. I changed the title a little bit. You will see on the screen. This could be a method for the 21st century. A little more toned down is just a nice theory or model that we can use to help us in setting cut scores. Much of the session today will cover kind of an introduction of IIT, which is an acronym I'll be using for information integration theory. So I'm assuming that most people aren't that familiar with it, and so we'll spend some time on just hoping to get people more familiar with it. Next slide, Steve.
Dave,
Yes.
One thing, someone said if you could speak a little bit louder, please.
Oh,
Also,
sure.
I was remiss with some of the housekeeping. Attendees, please note that everyone is on mute, but there is an ability for you to interact with us through the dashboard. There's a chat functionality as well as a question functionality. So we'll stop along the way and take questions, and we'll have time at the end for some Q&A. Also, we will send the slides out to you, and we'll also send you a link to the actual recording of the entire presentation. So, Dave, sorry about that. Please continue.
Yeah, that's okay. I hope I turned my mic up a little bit, so hopefully it's better now. This slide shows my personal issues with current cut score methods. This is the only slide I have that is that talks about other methods. And as it says, these are my personal issues. I've used different methods over the years. And so here are a few. I'll go through them. First of all, there are many methods or variations of methods, probably hundreds of them. And as I look over them and read about them and try to understand the differences, I wonder why we have so many. Now that's ironic a bit because I'm presenting another one today. However, there's a reason why we haven't seemed to be able to find one that we can be happy with as an industry, or one that rises to the top. There is a popular one, or maybe even two, but they haven't really, in my opinion, and this is, like I say, personal, hit the mark yet. Another reason is the cut score point seems almost predetermined. I've had colleagues and clients and others joke about it. Why go through it when we know it's going to be 70%, for example? I've always wondered about that. And maybe number three is an answer to it. The methods, the modifications of the methods, they try to direct and conform judgments. You add item statistics, you provide feedback to the raters, you have discussions among the raters. I've seen a dominant rater in a discussion certainly take over and almost require all the other raters to conform to his way of viewing the task. I've always been uncomfortable with that, and it's done in the sense of adding more information and helping the raters, but I think it does, maybe doesn't do more harm than good. Also, while there is inter-rater reliability, there really is no really quick and strong check on the consistency and quality of the judgments. The rating task also is difficult to do. To judge, at least in the some of the test-centered models, to judge how many people might answer of a certain performance level might answer a question correctly. It's not an easy thing to do. And then finally, I think all of this results in somewhat of a little nagging lack of confidence in the cut score. I've certainly felt it. Like I say, these are my personal issues. I've read most information on cut scores. I've tried to become familiar. I've had to use them in a number of testing programs. So I'm wondering if perhaps there's another way. Maybe we can look elsewhere. So let's go to the next slide, Steve. I'm not seeing it, Steve.
Okay.
There it is.
There.
It just came. Thank you. So why propose another method? Well, maybe we can solve some of the issues. And perhaps for added value. IIT, for example, should be able to work for many other judgment tasks we do typically in testing. For example, even today at Caveon, we're using IIT to judge gender bias in items and to evaluate, as another project, to evaluate the alignment of an item with an objective. And I do know there are many others, areas where they're used, and a little bit more on this later. And we're seeing some promising results, so I'm excited that it maybe has more generalizability than just with cut scores. Just a little bit of background. Well, this particular theory came from the cognitive sciences. It has 50 years of theoretical and scientific support. I actually learned of this method when I was a graduate student in the mid-1970s and used it for a study. And I'm going to present a little bit of those results. And it has nothing to do with cut score setting, but it does illustrate a bit how useful this model can be. Next slide, please, Steve. For your, I don't see the slide yet, but it'll come up here. For your interest, I've produced a slide with some references. The individual mainly responsible for the development of IIT is Norman H. Anderson from the University of San Diego. Here are 3 textbooks edited or written by him that are very useful. So if this is a method that's interesting to you, I would suggest picking these up. And like I say, you'll get these slides, so you no need to copy this now. Next slide, please, Steve. So just to kind of understand a little bit how it works. Now, I know that many of you responded to an invitation to go out and do a little item rating task on Caveon's review tool called Scorpion. So many of you were able to do that, and we'll talk about those data. But just a little bit on integrating information. This slide shows 3 fruits on the right side and 2 dips on the left side. And the task is to combine the fruits with the dips and rate the combination that is preferred by you. So think about that just a second, and we'll go to a poll question that asks you to pick your most preferred combination of fruits and dips. Now the 2 on the left are chocolate and caramel, and you see what the others are. So let's go to that poll now, please, Steve.
Sure.
Oh, by the way, the poll technologically could only show 5 of the 6 combinations, so I apologize. I already removed the caramel and orange slice one, thinking it was low likelihood of being selected anyway. So I apologize, it's just a limitation. So please make your response.
Okay, it looks like we have people actively voting. We'll give you a couple more minutes. I know this is a hard decision. I couldn't decide either. Have about 75% of people who voted. Okay, just about 10 more seconds. Get those last minute votes in. Okay, so I'm going to go ahead and close the poll now, and we'll share the results. Okay, so are you seeing those results, Dave?
I am seeing them. Thank you. So as we see, chocolate and strawberry is preferred by about half of you. and caramel and apple slice by almost the other half, and a few people like some strange and unusual combinations in between. So hats off to you. I appreciate you conducting the poll, and I think just very briefly, the next slide please. Kind of from the poll data, we learn a few things about information integration theory. I guess it's coming up, right, Steve?
Yes, it should be up.
Okay, I see the poll slide. Okay, so first of all, there are differences in your top choice, and we just went over those. This is normal for judgments of food preference. But more importantly, you were able to combine or integrate the information quickly, imagine the taste of the combinations, rate the combinations, and then make your top pick. This is kind of the basic fundamental task within information integration theory, the ability to integrate different sources and create a combined judgment, and is critical for the whole theory to operate well. So much of what we do, next slide please, so much of what we do requires, and I'll say probably everything we do requires integrating information and making judgments. So I've just listed a few examples here: choosing a place to vacation, buying a car, leaving a job, choosing a mate, voting, picking foods to eat, and everything else we do. We're constantly integrating information. We're then judging it, rating it, eventually deciding and acting based on that value. How we do all of that is how we do that cognitive part of those tasks is explained by IIT. Next slide, please, Steve. And I might add, even judging the difficulty of test questions is a task, more specifically one we're going to talk about today. But it is very similar to any of those other tasks we do in life. So this particular chart came from Wikipedia. It's a schematic of how IIT works. On the left column is a large S's, which refer to physical stimuli in the real world, like you see a car, or actual physical car. And the small s is your valuation or your judgment of that car. I read about a new Dodge Charger that has 707 horsepower coming out this year in 2015. I wanted it. I judged it very desirable, and I know I'm not going to get it. It's too powerful. It's a four-door sedan for a family car, and it will be vetoed as a purchase. But still, I'm able to value it in my mind, integrate it with other pieces of information, such as how my wife will react, and then I can produce a combined integrated value and at the same time produce a likely response, which in this case for the car would be a non-response. And then actually the big R is the response, or in my case, not doing anything about it. Now, everything in the box in the middle is not directly observable. We infer what is occurring and what is being combined from the responses. So next click, Steve. And that's the area we're most interested in, is that integration function. How is that working? How do we combine those small s's together? And Norman Anderson proposed cognitive algebra models. The most basic ones are additive and multiplicative. So in the case, so hit the click, please, Steve. So we either add those together to form our combined value, or click again, Steve. It's coming. There it is. It's a little slow. Or we multiply them together. There are other models too, but these are the more basic ones, the ones that have been studied, and probably the more common ones. So we're going to see a few examples of each right now to give you an idea of how they're different. So next slide, please, Steve. So the additive models. As I said, individuals are adding the stimuli together before judging. This produces parallelism when you chart the data. So let's show an example. there we go. In this case, people, subjects, adults rated presidential statesmanship after reading 2 biographical paragraphs. Now, the paragraphs could either be 2 very positive ones, 2 very negative ones, or a positive and a negative, or a positive and a neutral. And what you see are those their ratings based on those different combinations. So the most on the far right and the upper point shows the most positive evaluation of presidential statesmanship was given when 2 positive paragraphs, biographical paragraphs, were written. And you can see the other judgments, but most importantly, you can see that the 2 lines are linear and they're parallel, indicating very strongly that an additive model is being used. That is, the judges are adding what they learned from one paragraph to what they learned from another one before they make their judgments. Let's see another example. So this is with 5-year-olds making the judgments. They're asked to evaluate how much a cookie how big a cookie is there that they get to eat. And they're given the size of the cookie in terms of length and width. Now, if you have to judge the size of a cookie, you would almost always use a multiplicative model, because that's how you determine area. And you'd probably add another dimension in as well. But what's interesting is that 5-year-olds don't do that. They use an additive model. They simply add the length and width together to get to their judgment of size, or how much there is to eat. So it's interesting. Developmentally, you can see how maybe additive tasks can then become multiplicative tasks. So that's just an interesting example, but this particular one from the parallel lines indicates an additive model is being used. Next one, please. Now, examples from multiplicative. This is a little more complicated to envision, but you can see it clearly in the graphs because it produces a linear fan. So let's show an example. So this is these are people judging the value of a lottery ticket, and they're given the odds of winning and the value of the ticket. So if you look at the bottom left part of the chart, you see that when the odds are really low, one chance out of 6 in winning, then the judgment of the lottery ticket, the judge value of the lottery ticket, is almost the same regardless of the actual value of the lottery ticket. But as the chance of winning, chances of winning goes up as you move to the right part of the graph, then the 50-cent one is almost twice as valuable as the 25-cent one, and it has significant value. And almost as much value as the lottery ticket is worth. It's judged 40 when the ticket is worth 50 cents. So you can see the linear fan, and that really, when the probability is low, almost no value is given to any of the tickets. Let's see another one. This might be more is closer to the kinds of things we look at in testing. These individuals were asked to judge the likableness of a person given a combination of an adjective and an adverb, and those are on the right side. The adjective is honest. The adverbs are all listed along the bottom. So slightly honest is given a rating just a little above 0, whereas somewhat honest is given a rating almost around 30. And you can see when the honest adjective is there that as you move from slightly up to quite and very and extremely, that the ratings all increase, whereas they all decrease if the adjective is dishonest. What's interesting about this chart is you need is to notice that the adverbs on the bottom are not equally spaced. That is, the distance between slightly and somewhat is smaller than the distance between somewhat and fairly. Those differences in IIT are significant. Knowing that those are differences, that's an interval scale. This isn't just ordinal, where we rank these things, but we actually have quantitative information regarding those adjectives. And that's going to something that I'd like you to understand as we go later in the session today. So I hope you got a pretty good idea of the different, at least the additive and the multiplicative model. Now, I wanted to show you, IIT applies also to non-humans, at least to pigeons, which is a study I did back in 1976, where I researched food preferences in pigeons as I was being trained as an experimental psychologist. The pigeons had to integrate two pieces of information. One, the type of food, and you can see along the bottom of the chart, there were three types: wheat, buckwheat, and hemp. And the amount of work they had to do to obtain the food. The bottom line is the amount of work, and that's a lot of work. They don't get paid very often. They have to pick the little key in the box they're in a lot to get even a little bit of whatever food is listed. You can see from the pattern, at least I hope you can see from the pattern, that this is a linear fan. So the pigeons were evaluating the food in the context of how hard it had to work for it. And when it was a lot of work, show the bottom line there, you can see that while the differences between the foods was still apparent, they weren't judged very highly in general. Wheat was not judged highly when they had to work really hard at it. So this gave a little bit better. I mean, pigeons, you can imagine, don't respond well to surveys. And so it was to find a way to get them to do this. It seemed like a great model to explain and to provide judgments. Now, this works at the individual level too. So I'm going to show you the 4 pigeons in this study on the next slide. Now, there are a couple of interesting things about this slide, and I'm treating this slide as if it applies to humans as well, which it does. Humans would show similar differences. You can see how the linear fan exists in all 4 of these pigeons, but there are certain differences in work schedules. They're not equally spaced, for example. You can see most starkly the differences in food preferences. Wheat was generally preferred by pigeons, but for the pigeon on the bottom right, hemp was the more strongly preferred than wheat. I know, maybe it was surprising to me, and maybe to you, that pigeons have show such differences, consistent differences in food preferences. But notice the differences on the bottom lines of each chart. I mean, those are quantitative differences. It can be used then for making important decisions. Perhaps Purina would make different decisions about the makeup of its Purina pigeon chow when when it comes time to change the brand a bit. So anyway, let's basically I want to use using these pages to show the generalizability of the model as a cognitive model, as a scientific model, and its breadth of where it has been applied so far. Okay, so let's go to the next slide, Steve. So just a little bit of a pause, mid-webinar summary from what we've seen so far. There's easy visual evaluation of overall ratings and individual raters. There's better understanding of the judgment process. How are they combining? How are they making those judgments? What model is it additive, multiplicative, or is there another way? What is we've seen the production of results on interval level scales, and late in a minute we'll see item difficulty ratings on those scales. We see the quantitative comparison of performance levels, such as those work schedules or probability of winning, and so we see great places where we can compare different factors quantitatively. And this wasn't shown on the previous slides, but there are practical benefits: quicker, easier, less expensive. I think these will pan out Support for that last point, the work we've done so far is that there's no need to travel to a setting. You can do this online. No need for meetings even. No discussion of items. No supplying of additional data. The process is much quicker. Now, to be honest, because you're integrating sources, a rater may have to do 2 to 3 times the number of ratings. But it's all quicker and easier, a simpler task to do. So I think that those are some good practical benefits. So let's go to the next slide.
Dave, I wonder, since you've just set the stage of kind of overviewed IIT, and now we're going to get into its use for cut scores, I just wonder if we should pause and see if there are any questions generally about IIT before going a bit further.
Yeah, I'm happy to pause a second for that.
And there aren't any questions, so let's keep going.
Okay. Now, the data we're going to look at here is yours, or at least a bunch of you who completed this task. You were asked to go to the site and provide a rating of difficulty for 3 math questions, each for students that have completed the 2nd and 10th grades. So there were 6 total ratings. You're integrating item content with your knowledge of student performance at 2 different grade levels. Now, just a little brief on this task. I'm a bit amazed that the results came out as nicely as they did, considering you weren't giving very good instructions. You were using new technology, and maybe none of you were real subject matter experts in K-12 math. I know I've got a few people that said, I don't remember what I did at the 2nd grade. And so I'm surprised and pleased that we got pretty good results. So I want to show first some typical individual ratings. So let's go to the next slide. And after the individual ones, we'll show the combined ones. So here's rater number 12. The points, you can see their rating estimated difficulty. Those of you that didn't participate, the individuals rated the difficulty of an item they saw. The data points on the left of this chart are the easiest item, which was an addition item. The points on the very right of this chart are for an algebra item. And then the points near midway but to the right are a square root item. And the line on the top is for 2nd graders. And those would be viewed as more difficult items for those individuals. And the purple line below is for 10th graders. So that's raters number 12. So are those lines parallel? Do we have the additive model working here? Well, it's hard to tell with individuals. But let's go to the next one. So this is rater number 2 on my list. And again, are these parallel? Kind of don't look parallel. So let's go to the next one. So this is maybe a little more parallel than the others. This is rater number 6. So, graphically, things are a little ambiguous. Let's look at one more rater, one that for some reason either didn't understand the task or didn't try hard. It's obvious that the data from this rater is kind of messed up. And so I went through all those results and I removed any very strange results from the analysis, and this was not the most strange one. So all in all, we had, as of about an hour ago, there were 54 people that had completed the ratings. I created charts yesterday based on 47 of them. So let's look at the combined data. Did we skip a? Hold on just a second. Yeah, we skipped a slide, Steve. Could you go back one place?
I don't think I've got it, Dave.
It's slide number. Did you hide a slide? The next slide is really, really important, Steve. Could you check really quickly and unhide? Yeah, that one. Unhide that one. Sorry, I think I gave you some wrong instructions.
Okay.
Thank you. We're back. So a little technical problem. Okay, here is the combined data. There were 47, as I said, people that I was able to use the data for. This looks like a linear fan. This looks like we were using some sort of multiplicative model. I want you to notice that the addition items were all judged fairly easier than the other items. The square root and the algebra items were pretty close in terms of their general difficulty rating, and quite a distance from the addition item. The second graders obviously found all the items, people judging for second graders found the items, rated the items more difficult. But is this truly a multiplicative model? So let's go to the next one where we, by the way, Scorpion produced these results fairly quickly and also produces an analysis of variance almost as quickly. So the next slide shows the statistical evaluation of these. So the analysis of the variance for the items, the differences between the items was highly significant, the F-score, and the probability of that F-score is 6, a point followed by 34 zeros and then, sorry, followed by 35 zeros, then 0.67. So it's extremely low probability that the result was achieved by chance. Same for the proficiency levels, or the difference between the grades, a highly significant F-score. But more importantly, and hit the little click button there, Steve, please, is that the interaction effect is significant. That indicates the two lines are definitely not parallel. The chance of that F-score is around 1 in a million. 10 zeros, so longer than billion. And so it confirms the multiplicative model is being in use here. Now, we have to caution a little bit. First of all, it doesn't mean a whole lot. You continue, whether it's multiplicative or additive, you still can continue with using the data either way. It doesn't really make a difference. It's just a better understanding of what might be going on in the judgment process. However, in this case, we had some strangeness. That is, we only had 3 items, and one was really easy, and the other 2 were somewhat difficult, and there were only 3. The instructions were not great. They were very brief. We didn't use subject matter experts, which may have come up with a different set of ratings. And perhaps we're dealing with the way I set it up, a ceiling or a floor effect. All these may have combined to produce this multiplicative effect, and the results might have been different had we've done this a bit more consistently and not as just an exercise for a webinar. But we're going to make the assumption that things are great, so and move forward. But I just wanted to give those little cautions. So I want to show 2 examples of programs that have used the IIT rating. This was a Hewlett-Packard certification exam. I think there were 10 raters. They were judging items, much as the task we just described. There were 100 items in this case. And they were able to see some nice separations between the highly qualified, the ideally qualified, and the absolutely unqualified as performance levels. So nice. So in this case, they look quite parallel, but maybe there's a little bit there that isn't as well. So Let's go to the next slide. Shows an exam. By the way, these data were presented at ATP in 2013 by representatives from these programs. And they were presented in a dissertation by Chris Foster at the University of Massachusetts last year as well. So you can get a copy of that dissertation if you're interested. These, but you look at the Excelsior College exam. This is for a low-level nursing exam. And they were looking to judge people where they could assign grades. Highly competent, competent, marginally competent, maybe a C grade or a C minus or something, and weak, which is a D or failing kind of grade. So you can kind of see they were looking. And what's nice about this chart is obvious ability of the raters to use IIT to judge the items by different performance levels. So just so you know, each rater here judged every item under 4 different conditions. And you may not have noticed those that did the task, but IIT always randomizes what is to be judged. So these weren't put in any kind of order initially. These were all presented randomly, and under those conditions, the judges were able to provide some very stable and consistent and useful results. So just a couple of examples now. Let's go to the next slide, Steve. So what can we do with results like this? Like I said, whether it's the model is additive or multiplicative, interpreting the results, using the results is the same. You've confirmed a model. You see that raters performed the task consistently and properly. Well, those that didn't were not included in the task. They were easily discovered. You can use the marginal means of the item ratings as difficulty estimates on an interval scale. And you can also use the marginal means of the performance level ratings as cut scores or for other purposes. So we're going to do a little of that right now. Next slide, please, Steve. Yeah.
Before we go ahead, on the last slide with the Excelsior College exam, there's a question: do the raters still need to discuss and come to agreement on the meaning of highly competent versus marginally competent versus weak?
You know, I don't recall exactly what happened in these cases, but what I believe I remember is that there was, the raters were not involved in that, but the program, different individuals at the programs got together and came up with the proper language. The raters, when they rated every item, they had that description for the particular level that they were rating. For say it was the highly qualified, that was in front of them with the description, and then the item was also there, and they were able to judge the item difficulty for that particular performance level. The raters themselves did not come up with those descriptions. Those were developed by the program. Maybe some value to doing that. It wasn't the case in these cases.
Great, thank you.
Okay, so how to set a cut score using IIT. At this point, the process is not probably very different from what occurs with other methods. It is always a challenge, and I'll emphasize that. Always a challenge to get from ratings or judgment data to a proper or corresponding value on a score scale. The judgment and rating data isn't answering questions, it is rating something about, like rating how many people or what % of people answer a question correctly, or how difficult is an item. Whereas the score scale is how many you get right to pass, or how many, or what % you get right. Or it could be a theta value if some other score scale is being used. So that's a chasm. That's a barrier that you have to breach. You have to get over it. You have to solve it somehow. But it isn't ever easy. There's some logic and art and trying things out involved. I'll show you one method. Next slide, please, Steve. So I'll show you one method that I thought seemed reasonable. And the first step was to come up with a cut score based on simply the ratings. So here's how I did it. So second grade, I came up with a cut score of 4.95. Now, how I did that is I took the average difficulty rating of the items, the 3 items in this case, which was 15.05 for the second grade. And then, because of the way the scale was set up, I reversed it. I subtracted them from the high end of the scale to get 4.95. So depends on how you set up the scale, you wouldn't have to. If you were judging easiness rather than difficulty, you wouldn't have to reverse that scale. So I came up with 4.95. For the 10th grade, I came up with a cut score of 15.47. Now it's obvious these are on a rating scale of 0 to 20. These right now have nothing to do with a bunch of items being given on a test at some point in the future. So we need to get to that point. But I feel pretty good about good estimates of cut scores based on the rating scale. And I could also assign some error around these cut scores. So there are raters certainly aren't consistent exactly or perfectly consistent with each other. So maybe my 10th grade one would have an error band of 1 or 2 points. And I could use that later on as well. But I'm just going to forget about that one for the point of to make these points about the cut score. But keep that in mind that error will influence a little bit where the cut score is placed. So next slide, please, Steve.
This is the one you want. I incorrectly hid, so I think
okay, well, leave it here. That's okay. Go back to it. Let me just show.
Okay.
This is I just took the mean of the items for the second grade, which is the line in the black, and gave it, figured out it corresponded to a rating, an average rating of 15, and then I just I didn't actually invert it, but I subtracted from 20 to get the 4.95 value. So it's just a graphical display of the last slide. Next one, Steve. Okay, so now I want to go from that IIT rating to a score scale. So I have the ratings-based cut score. So my question is, how many items, or what percent of items, have IIT difficulty ratings below that IIT cut score? That number, or percent, becomes an equivalent cut score on a score scale. So this is the logic, and I'll graphically show that in just a second. And as I said, there will need to be some adjustments for error. But let me read that first paragraph again. For a particular IIT ratings-based cut score, how many items, or what percent of the items, have IIT difficulty ratings below that IIT cut score? And that would basically become the scale. If I have a percent or a number correct score as my score scale. So let's go to the next one, which I kind of show this graphically. Now, in order to do this, I kind of beg for your imagination a little bit. I extended, instead of just having 3 items, let's pretend we have 100 items. And that this particular graph you see here is a cumulative frequency distribution of those items by their mean ratings. So I didn't know how to show it with only 3 items, so I needed to make a little better chart. So please, please pretend. Okay, next, click once, Steve. So setting the 10th grade, one more. That has a cut score of 15.46. You see that down at the bottom. Next one. You go vertically till it hits the cumulative distribution, and then hit it again, Steve. And then goes over, and one more time. This shows that 80 items have a difficulty rating, a mean difficulty rating less than the 15.46. So that 80 could be, in this case, either a percent or a number correct to serve as a cut score. If you have some error associated with that 15.46, that error can be transferred over, so maybe you're more comfortable with, say, a 74 or a 75 based on the error, some lower point of the error or the higher point of the error, depending on what you're looking at. So it'd be nutty, but let's say this particular test were also used to test second graders. So let's go to the next slide, Steve. This really works the same way. You can just click on, so for second grade, the cut score of 4.95. Keep going, Steve. And one more, and one more. Would mean that a person would have to answer 7 of the 100 questions to pass at the second grade level. This would be something that might be for an adaptive test or something that would have a wide range of items. Again, I apologize for having such a strange little 3-item test, and it didn't help with the illustration here at the end. So that's one possible method for taking IIT data, converting them to getting a cut score and converting that cut score to a score scale that you're going to use on your exam. I think it makes sense. Obviously, would need some research, but you have a nice, solid cognitive science method underlying your judgments. And then you have a fairly straightforward method for obtaining a cut score and converting that cut score to a cut score in your score scale. So Steve, next slide, please. So that illustrates one way. I assume that many of you involved in setting cut scores throughout your careers would come up with better ways than I did of making a cut score. We have a certification program at Caveon that we'll be introducing early next year for a certified security professional, which we will use a method like this or something very similar to it. We'll definitely be using IIT to evaluate the items, help us create our exam in general. But besides determining cut scores, I think there are many other areas in testing where we use judgments. I know a few. There are item accuracy reviews, essay scoring. Currently, we're involved with, as I mentioned before, a review of items for gender bias. But we could also, look at race or age or any other characteristics. Also judging item quality in terms of how they align with objectives, how closely they meet up with objectives is a great task for IIT. And there may be others. I'd be welcome to hear more places where judgments are used in the test development process. If you have some and you'd like to offer those. But at this point, we're finished with the main presentation, and we have a few minutes remaining for you to ask any questions you have.
Hey, Dave, we've got some questions. The first one is, how much longer does this IIT method take in comparison with other cut score studies? The person indicates that they're thinking the one question has to be answered multiple times, and that means more of a time commitment from SMEs. And does that affect how you recruit SMEs?
Yeah, that's an excellent question. I've seen a few comparisons like that. It appears to be a wash, or maybe the IIT method is a little faster. And that's not counting travel or any kind of setup that you might have to do. I think if you have to travel to a cut score meeting, that pretty much answers that question there. But assuming it's all online, the method probably may take about the same amount of time if you're maybe judging 3 levels and all the items. The rating itself is usually very quick. There's no discussion involved, and so that's what kind of makes it either a wash or a slight advantage to the IIT method.
So I think this is sort of related to the first question, where we had multiple levels of performance, Dave, in the Excelsior example. And this question is, do the standard setting panelists need to rate each item once for each performance level on the exam?
Okay. Again, a great question, and the answer basically is yes. However, certainly a matrix sampling approach can be used. So you have a choice, if you're setting up such a study, to ask 5 raters to rate all the items under every performance level, or 10 raters and give them each half of the task, but more in a random matrix sampling fashion. So you have that choice. You can use fewer raters, but they have to rate more, or more raters, and you can give them fewer ratings to look at.
Okay, so I'm sorry, go ahead, Dave, sorry.
Oh, I just said I hope that answered that question.
Okay, so here's one. Are ratings needed for all items in an item pool, or could you interpolate based on empirical item difficulty if you have examinee data? So, you know,
Yeah,
how you showed how you generated a cut score for 100 questions based on 3. I think it's related to that. Can you do that?
You can. Yes, you can. I think there's research involved, and you probably want to demonstrate it. That's working well. But certainly, if items share a lot of the same properties and same statistical properties, I would expect rating 1 would, using IIT, but IIT rating would have some generalizability to the others. So it's an interesting question. I've not thought of that one before, but it seems like a reasonable approach to me.
Okay, so with the example, Dave, the little sample we did with the 3 questions, 2nd and 10th grade, were the raters told about the meaning of the 1 to 20 score? For example, what does a 10 mean? How subjective was their rating? How much direction did you provide?
Well, I already said it's a pretty lousy set of instructions, and and people did very well, and none of them probably were experts in math. So it's pretty robust for instructions, but I would, if I were doing this, I may try to set some limits. Say this is an example of a 19, or this is an example of a 3. To get them in the frame, giving them a frame of reference. I didn't do it this way. It still turned out pretty good. I don't know how absolutely necessary that is, but I think it would be helpful.
So here's a question, Dave. Someone asked, what is the tool that was used for gathering this example data?
Oh yeah, okay. We've seen a need for a kind of a review tool for some time, and so for the projects that we do for our clients is that we built this tool called Scorpion. Some of you went out and used it. It's good. It helps facilitate these types of reviews, communicating with the reviewers, giving them instruction, and then also along the way tracking who's doing what progress has been made, and then finally putting some graphs out to see results and even that statistical analysis. So that's our Scorpion tool. It's in a beta test. If some of you want to participate in the beta test, you're welcome to contact us.
So we're running up on the hour. We do have additional questions, Dave. Are you okay if I throw a few more at you?
Yeah, I have it still with 3 or 4 minutes left, so yeah, please do.
Okay, how does item impact data factor into the rating process?
Now, item impact data, I'm assuming that means you have some item statistics, but I'm not really entirely sure what that term item impact means. But I'll answer thinking that it means if you already know how some of the items are performing. I think I mentioned in an earlier slide that I'm not comfortable with asking people to judge an item difficulty because they're subject matter experts and then giving them statistics that show how the item works. I know there's logic to that. I can see the logic. I don't necessarily agree. I think all you're doing is, I mean, if I were judging, and I would look at the item statistic and use that instead of the text of the item and try to use my expertise. So I think it interferes more than helps.
Interesting. Now here's one. Did Chris or has anyone done any comparability studies between this IIT cut score method and other methods, and do they result in similar cut scores?
Okay, good question. Christopher Foster is the person who did that dissertation with Hewlett-Packard data, Excelsior College data, and I think he looked at some TIMSS mathematics data. And that's all included in his University of Massachusetts dissertation. I can get you a copy of that. He did compare Angoff and the IIT methods, and I came up with similar sets of ratings or cut scores. So it's a fairly extensive dissertation. I think you'd be interested in looking it over since it's directly relevant. I should have put that as one of the references. Sorry, I didn't do that. And Christopher Foster, by the way, is my son, so that connection isn't coincidental.
Dave, how acceptable is this method, particularly if someone's dealing with ANSI accreditation and and it's similar to the last one, has there been a parallel study side by side with this IIT versus Angoff?
You know,
so
I understand the question, Steve.
Okay.
There's always resistance to new things. Accrediting boards probably have a little more resistance than a program just trying to do a better job at something. I expect there'll be some resistance, and it'll be necessary to, in some initial studies, to show comparative results, or at least show the good scientific basis of IIT, along with the consistency of what raters produced and the logic behind setting the cut score. If I were on an accrediting board, I would think those would be more important than simply a method that is popular today. Anyway, so I think there's going to be resistance to answer the question, but I think that will overcome in time. First of all, there are, like I say, hundreds. There's probably been no version of the Angoff ever presented to an accreditation board that was like any other version of the modified Angoff that was ever presented to an accreditation board. So, you know, they use the label, but I'm not sure they see the subtle differences between them. And there are always subtle differences.
Well, Dave, that brings us right up against the hour, and we always want to keep these at 60 minutes or less. There are a couple of other questions, but I think we can respond to those in our follow-up emails and tackle it that way. So, Dave, I want to thank you for putting this presentation together and always challenging us to be thinking of new ways, better ways to tackle old assessment problems. I want to thank our audience for spending an hour with us. Look for information on next month's session, and thanks so much, everybody.
Thank you, all of you.
Have a great day. Take care.
Bye-bye.